All right, so welcome everyone to this talk. We are going to talk about Angular. And you're the few and the brave who decided to come to an Angular talk at this conference. Because there's a lot of React stuff, there's a lot of Microsoft stuff, and only a few Angular talks, so thanks a lot for coming to this one. So we are going to talk about Angular 8, but to be very precise, the Angular team doesn't want us to talk about Angular 8. They even created a Twitter account for that a couple of years ago to say that it's just Angular. So we're not supposed to say Angular 6, 7, 8, 9, whatever. It's just Angular. So the rule really is that when we talk about Angular 1, it should be Angular JS. And when we talk about anything else, so Angular 2+, usually, that's just Angular. So with that out of the way, it's now going to be an introduction to Angular. So a few words about myself before I get started. My name is Alain, or just Al. I'm a GDE in web technologies, more specifically Angular, a little bit of Google Maps as well. I have a Java background, started doing full stack development a long time ago as a Java guy, and then in 2011 got into AngularJS, and that was it for me. I was like, wow, front end is actually fun. So I got into AngularJS, and then Angular, and then started my own venture with AngularTraining.com. So I do consulting, training, and basically all I do every day is talk about Angular or code with Angular. So that's my life. I'm based in Sacramento, California, where I organize the GDG Sacramento meetup group and the Angular meetup group as well out there. So again, everything I do is really Angular related one way or another. So what about this room? Any Java developers in the room? Yeah, not too much. It's a Microsoft conference, really. So C#.NET, yeah, a lot more. Anyone has any experience with Angular 1, AngularJS? Okay. What about JavaScript? Okay, most of the room. TypeScript? Pretty good too. And Angular 2+? A little bit. Okay. So I'm going to start with the basics, really. It's an intro talk, so we're going to start with the idea where Angular came from, and then we're going to get into what we do when we build an Angular app. So before Angular, we had all of these technologies, PHP, ASP, JSP, all of these things where what you would do is make a request to a server. And that server would use a database, and with that database, get some data, build some HTML, JavaScript, CSS, return to the client, and render things. That's the basics. That's how the web still works for the most part. Today, 60% of the internet just still works like this to date. Not great, though, because every time you click on something on your page, well, you make a request to the backend, and you rebuild something and return it to the client. So if you have 1 million people on your website, you're basically building 1 million times the same page, kind of. So things have changed, and with AngularJS, that was really one of the very first frameworks to go into that direction. Now the front end is completely independent from the back end. So when you build an Angular app, you build something that's going to run in the browser, and that doesn't even care or know what is on the backend side. Meaning it could be any technology on the backend, doesn't really matter. The front end is completely independent. It's just its own bundle of HTML, JavaScript, CSS running independently in the browser. So that's a big change in terms of mindset, because you can have really two different teams working on the front end and the back end, which is pretty good, because working with a database is really not the same thing as displaying data and dealing with, layout issues and caching on the browser, that kind of thing. So that's the idea behind Angular. Now, a little bit of Angular history. So Angular started a long time ago with AngularJS. 2012 was the official 1.0. And in the AngularJS era, so the Angular 1X between 2012 and 2017, there was no real predictability on when things would happen. So that's the timeline. Sometimes you would get 2 or 3 different versions a year, sometimes nothing for 1 year, 1.5 years. And some of these versions, they would have breaking changes, and some others not. So from one day to the next, you could end up with a new version of AngularJS that would break your code. And that was not ideal. So when the Angular team started with Angular 2, it was a full rewrite of everything. So everything changed with Angular 2. And they said, well, we're going to learn from that because people didn't like it. Of course, you don't want your project to break from one day to the next because Angular decided to change things. So with Angular 2, things are different. And now we have a new major version every 6 months. So that's predictable. Every 6 months, we get a +1 of the major version. That's why we are at Angular 8 right now. And Angular 9 is actually going to happen very soon, next month, within a few weeks. And then 6 months later, we're going to get Angular 10. So with that in mind, it's predictable, easy to know when it's going to happen. And that's the only time when you can have breaking changes in the framework. So every 6 months. And in between that, you know that you can just update to the latest. Nothing is going to break. So if you're using 7.1, you want to get to 7.2, no problem, just update, everything's fine. So Angular is widely used. And at Google alone, they are using Angular on 1,500 different projects. And that's one company. So that's big, right? 1,500 different projects at Google. And it was 800 just 2 years ago. So they pretty much doubled the number of projects that they are building with Angular at Google alone, which is pretty big. If you want to see more examples of things built with Angular, there's this website, madewithangular.com. And you'll see that Angular is very heavy on the enterprise side. So most companies who use Angular would be, banks, airlines, financial institutions, healthcare, companies that need something safe and reliable to build on, really. So Angular is made with TypeScript, and that's one of the reasons why it's a very appealing solution for many people. Because TypeScript, well, if you come from a Java, C#, .NET background, when you see TypeScript, you just know it, basically. There's nothing to learn. It's like, oh, OK, I know that. It's a class. There's a constructor. All of these things just make a lot of sense. So it makes the adoption of Angular super easy, because you'll see the code, and it starts making sense right away to you. So if you're a full stack or backend developer, getting into Angular is just very easy because of that. So that's one main benefit. The second benefit of TypeScript is that it is going to transpile down to ES5 JavaScript. And ES5 JavaScript was the version that was specified in 2004, so a long, long time ago. And because of that, browsers are pretty good with ES5 right now. You get 99, 100% of support of ES5 in all browsers, so that's pretty good. ES6 was released 2015. And the support is most likely 97, 98% across browsers. So nobody's at 100% yet. With TypeScript, though, you don't have to care about this, because TypeScript, again, is going to take your code, no matter what you use in terms of features. The latest interesting feature from TypeScript, you can use it. It's going to end up being transpiled into ES5 that just works everywhere. So this is also a big burden that goes away when you use TypeScript, because you can write any kind of code and you don't have to worry, oh, is this going to work in IE? Is this going to work in Firefox? Most of the hard stuff is taken care of by the compiler itself. So that's pretty good. So we saw that Angular is being released regularly. It's using TypeScript. And it also comes with something very important. That's Angular CLI. So CLI is something that, well, we're going to use for everything, pretty much. You can use CLI to generate some code for your Angular project. You can use it to serve your code for dev purposes. You can use it to build your app for production, run your tests, run your end-to-end tests, lint your code, everything, basically. You can do everything with Angular CLI. So I'm going to start with a quick example of that and move on to a terminal here where I'm going to run ngserve. Ngserve is the basic command. So all of these ng commands, that's Angular CLI. And ngserve is going to go through my entire project, find all of the TypeScript code in it, compile all of that, start a web server, and serve my app on that server locally. So it's doing it right now. The initial start is a little bit slower because it has to go through all of the files, discover everything, compile, build, optimize, and then it's done. So we see compiled successfully. That's a good sign. Now I go to my browser, localhost 4200, I refresh this, and I see Hello Angular. So that's my Angular app running right there. And now that NGService started, I can just leave it go like this. And every time I make a change to my code, it's just going to see the change and automatically recompile, refresh, re-render in my browser. So I'm going to show that to you right now. Let's go back here. So I'm just going to change Angular to Angular 8, which I should not be doing, but it's just a demo. And I go back to my browser, and I go away, and it refreshes. I didn't do anything, and it says hello Angular 8. So that's Angular CLI doing all of that under the hood very quickly, recompiling a diff of what has changed, and refreshing my browser. So that's pretty good. So now I'm going to talk about components, which are really the most important thing to know about Angular. If there's only one thing to remember about this talk, that's the notion of components. Because when you build an Angular app, you're going to build a tree of components. So everything you're going to do, probably about 80% or plus of the code you're going to write is going to be components. So what is a component? Well, it's kind of like your own custom HTML element. So when you build a component, you build your own HTML element, you give it a name, and then you put it on the screen, and it shows up. That's really all it is. And any Angular app is going to be a tree of components. So in my basic example here, that says hello Angular 8, that's a component, of course. And that component looks like this. So that's the syntax to create a basic component. So it's TypeScript code. We have a class here. That class has one property, name, of type string. So that's one of the benefits of TypeScript. We can use types in our code, make things explicit. And in my constructor, I just initialize name to Angular 8. So very basic. That's all of the business logic in that component, not much. And then what turns this class into an actual Angular component is a decorator we have up here. So this block of code here is adding some extra information on that class to make it an actual component. So we add two different pieces of info here. The first one is this, the selector. The selector is the name of the HTML element. So in that case, it's going to be app hello, which means whenever I want this component on the screen, I just use that tag name, and the component is going to show up. And the second thing we have is this template. So that's the actual HTML that is going to render whenever I get this component on the screen. And you have everything here to have an up and running component. So I have 17-ish lines of code to do this, which is pretty good. And most of it was actually automatically generated by Angular CLI, which I'm going to show you next. One last thing on that component. So this syntax here, this is an Angular expression or an Angular interpolation. And what this does is that it's telling Angular that this here has to be evaluated in the context of that component class instance. And that's why when we display this component on the screen, we see hello Angular 8 in our case, because this is going to be replaced with the following, which seems super basic, but it's actually very important to know about. So that's our component right here. If I inspect the source and go to the HTML elements behind it, you'll see that in our application, we have an HTML body. We have the app root, which is the main wrapper component around everything in our app. And then we have one component, app hello. And when I open app hello, that's my div, and it says hello Angular 8. So that's my component. It's really an HTML element that lives in the DOM, as you can see. But there's more to it, because this binding here is, well, that's what we call a data binding. And as soon as we define a data binding in a template, then what's going to happen is that if that data changes later, then the component is automatically going to see that and refresh the HTML that gets displayed. And I can demo that using the JavaScript set timeout, for instance. And what I'm going to do is tell Angular that after a few seconds, I'm going to change the value of this.name. And I'm going to change it to something else, literally something else. And this is going to happen after 5 seconds. So basic set timeout, that's regular JavaScript. And after 5 seconds, I'm just going to change the name. So I go back here, I move away from my laptop, it says hello Angular 8, and after 5 seconds, it just says hello something else. So Angular has its own change detection mechanism that takes care of that. And if we just change the data, it renders right away, which is really nice. So I'm going to remove this. So what I'm going to do now is actually build an app from scratch. Why not, right? We can do that. And the app I'm going to build is a simple license plate store. So why a license plate store? Well, because no one else has done it before. You can find a lot of to-do list apps, that kind of stuff. And I collect license plates. So I thought, well, that's pretty unique. I'm going to build a license plate store. So let's get started with that. If I want to build my license plate store, I need components in order to do so. And in that UI, well, you can probably guess quite a few components already. This header up here, the navigation, well, that would be one component. So I can turn that into its own HTML element, and every time I need that header, I would just use that component, and it shows up on the screen. So that would be component number 1. Component number 2 would be this guy here. So this kind of marketing header with a title and a description. I'm going to make a component out of it, so I can reuse it on different screens as well. And then all of these different license plates. So that's one component. And that's another instance of that same component, and that's a third instance of that component. So we're going to have 3 different components to get started. So let's build them. So I go back to a terminal. And what I'm going to do here, so I open a new one, and I'm going to tell Angular CLI to do this for me. So ng generate component. And the first one I'm going to do is the navigation component. So the one at the top, this black bar, that's a navigation menu. So I run that, and from there, Angular CLI is going to take care of the difficult parts, which is generating the code and the template and everything for that component. And it's done. So now I have a navigation component. If I go back to my IDE, we'll see that a folder has popped up for this. And it has a navigation component.ts with all of what's needed to build my component. So there's a decorator, there's the name of the selector. So all of this was created from my command only. It even has a basic HTML template, but that's not what we're going to use, right? We're going to make something a little bit more interesting than just a paragraph. So to save us some time, it's not actually fully from scratch. I'm going to get some templates, because it would be painful to write all of that HTML and CSS. So I'm just going to copy-paste the template for that component in here. And now my navigation component is ready. So this one is very basic, doesn't have any business logic, it's just a menu. So that's really just that HTML that I want to reuse. So if I want to use that component, I'm going to go to my app component TS. So that's the main wrapper component that displays everything in my app. And right now, well, it was just displaying this app hello. So I'm going to replace that. And instead of displaying app hello, I'm going to change this a little bit and tell Angular that I'm actually going to use an external template file. So that's my app component HTML. There we go. No typos. And in that app component HTML, I'm just going to add my navigation at the top. So that's a basic layout for my application. And that's where the navigation component is going to go, at the very top of it. So now that I've made those changes, I go back here, and there we go. I have a navigation component on the screen. So that's the first one. Easy enough. This one was just HTML. Now we're going to build the second one, which is the Jumbotron. So this section here with the marketing message, welcome to our store, blah, 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 this is going to be its own component. This one is going to be a little bit more complex because we want to be able to change the title and the description. So we want to be able to customize what the component renders. And I'll show you how we can do that. So same process. I just go back to my terminal. I can generate a component. There's a shorter syntax for generate component, which is just NGGC. That's a little bit faster. And I'm going to call that one Jumbotron. So it takes a few seconds. There we go. Everything is generated. I'm going to get my template from here. Copy that. Paste it in my brand new component that was generated here. So you can see that every single Angular component has its own folder. In that folder, we have the CSS for it, the HTML, the TypeScript code, and even a sample unit test that gets auto-generated for you. And all of that is its own self-contained folder, so it's easy to find it. It's easy to know which files belong to which component. So I go here, replace that template, and the title and the description, as I mentioned earlier, are going to be dynamic. So I'm going to replace that static text with two different expressions, title and description, which means if I do this, I would have to declare these two in my component right here. So I'm going to declare title of type string and description of type string as well. Now that alone is not going to set any values to it. So if I want to be able to set some values to these two different properties, I'm going to use another Angular feature that is called the input. So if you know about React, that's pretty much equivalent to the props in React. So that's a way to say, well, this title is actually an input, so we can pass a value to it and use it in that component. So I use that input decorator on both of my properties so that Angular knows that I can set these two things from the outside. And that's exactly what I'm going to do next. So go back to my main component, get my Jumbotron to show up in here. And just for a first test, I'm just going to use it like this, and I'm not going to pass any data to it. And you can see that we just have this gray rectangle with nothing in it. And now I can set a title, welcome to our store, and a description. And that would be browse our collection of plates, for instance. So I save this, go back here, and there we go. We have another component that shows up. And this one, I can customize it, change the text, even make the text dynamic and change over time. Because of these bindings, it's all reactive at this point. So that was component number 2. So back to my slides. So we talked about the hello component. We saw that we can use an external template URL, same thing for the CSS. So every component can have its own CSS that's going to be scoped specifically for that component. Now these components, I just created 2 of them, but you don't have to create all of the components from scratch by yourself. The nice thing about having this notion of Angular components is that many different people have written libraries that give you most of the essential components that you would ever need for your app. So I'm going to show you 2 of those. The first one is Angular Material. So the website is material.angular.io. And if you like Android, or if you want to build something that looks and feels like an Android application, that's a perfect candidate for that, because these components are really the Android look and feel from Google. So if you want a nice looking checkbox with all of these animations on and off, and the CSS transitions, all of that, you get that for free, basically. Just npm install it, and then you can use those components, and you're good to go. Same thing for painful components, such as a date picker. who wants to write their own date picker, right? Well, you can just use that, and you're all set. And that's the only code you need to make it happen. It's just a component. So it's an HTML element that you use, and there you go, you have your date picker up and running. So these are the main benefits of Angular Material. The other main interesting thing about it is that it comes from Google, just like Angular itself, and the Material team is working very closely with the Angular team. So they release Angular Material at the same pace as Angular itself. So Angular is at version 8, Angular Material is at version 8 as well. And when they release Angular 9, then Angular Material is going to be at version 9 as well. So everything is always in sync, which is really nice because you don't want to be stuck with an old version of your UI components just because they don't want to upgrade to the latest version of Angular. With this one, it's safe. They're always going to be up to date because that's the main purpose of Angular Material. Another example I want to show you quickly is this library from VMware, which is the Clarity design system. So they also have their own Angular components. They also provide just basic UX and UI components, so just HTML and CSS. But they have the Angular wrappers for those, for most of them. And same idea. You get a date picker, you get drop-downs, you get labels, lists, all of these nice-looking components that save you a ton of time. So you want a model? Well, there you go, you have one. And you can just, again, copy-paste our example. Well, don't do that. It's not good to copy-paste, but you could. And it works right away. And you don't have to worry about the CSS or any of that. The other thing, especially for Material, it's easy to style. So if you want to customize the look and feel of these components, you can just change the entire thing. So the fonts, the colors, and everything. They do have a few defaults on the website and some default themes that you can use. These ones are very flashy, so I don't know many people who would use those, but you can really customize everything you want to make it fit your company's brand and CSS styling. So that's components. Pretty good thing because we can build our own, we can rely on components written by other people, we can customize components written by other people, and we can build our app on that. Next thing, I'm going to talk about data bindings. So data bindings are what make everything dynamic in our Angular applications. For instance, so I'm going to show you a demo. We saw that we can bind a value to something in our template using these double curly braces, the Angular expression. We can do the same to bind a value to a text input, for instance, using these square brackets right here. So this is a data binding from TypeScript, from your Angular component class to the HTML. And there's a binding in the other direction. This one is done with parentheses. So here I'm binding to the onClick event, and when I click, it's going to call the alert name method in my component. Super easy. So quick example for that one. I'm going here, find my bindings component. There it is. So very simple HTML template. That's a one-way binding to the property called name in my component. And then on click on the button, I'm going to change the value. I'm going to alert something. And in the TypeScript code for this, so name is set to a test. And when I click the button, it's going to call this alert name method, which is just going to say this.name was clicked. So let's give it a quick try. I go here. So the name of the value of my input is a test. And when I click the button, a test was clicked. So just with square brackets and parentheses, I was able to do some bindings between my TypeScript code and my HTML template. Nice and easy. Now, what if we want two-way data bindings? Because what I've done here is just one way. So if I change the value of a test to anything, when I click the button, it still says a test was clicked. And that's because changing the value of that input didn't reflect the update to my TypeScript component instance. If I want this to happen, Then there is a specific Angular feature for that, and it's called ngModel. So ngModel is a two-way data binding. And because it works both directions, we need both the square brackets and the parentheses to make this happen. So it seems a little bit weird at first, but yeah, we get used to it. And it's actually the only somewhat complex syntax to know about, so that's OK. And so if I want to enable that in my example here, let's go back to my code. And instead of having a binding to value, I'm just going to add the parentheses, square brackets, ngModel. I save this. And now when I go here and change that value to some other string, I click the button, and you can see that the string was also updated in my component instance. So that's a two-way binding. So these bindings, they seem very basic, but it's actually super powerful. And you're going to use that for a lot of things with Angular. For instance, here I have an example where this paragraph would have its color. So the color of the text in the paragraph has a data binding. And that data binding is going to be an expression that's slightly more complex than just evaluating a variable. This is going to evaluate as error. If it's true, the text is going to be red. If it's false, the text is going to be blue. So with a simple thing like this, I can make my CSS, my templates very dynamic. I can also use the same trick to show or hide some error messages. And just with that simple feature, I can go back to my button here. Oops. And add just one simple binding. So let's say I'm going to bind to the background color of my button. And what I'm going to bind it to is name. So why would I do that? Well, just to show that these bindings happen in real time as we change stuff in our app. So now I go back here, and if I type red, my button just turns red right away. I delete, I type green, it turns green. So these are data bindings in action. As soon as something changes, all of the listeners to that property get refreshed right away. And again, we don't have to write any code for this. Just defining the bindings is good enough. So that's data bindings. So quick recap, there's really 4 different ways to do data bindings. The first one we saw was the curly braces around a value, and you can just put that in any template anywhere, and it's going to substitute that expression with the actual string. Then you have a one-way binding from the component to the DOM using the square brackets. So you can bind to anything. We saw style, background color, value, any HTML property you can bind to. The event handler, so on click, on drag and drop, on whatever you want. You can add an event listener and trigger some code in your component class. And finally, you have ngModel that just works both ways. So if the data changes in the HTML or in TypeScript, the other side is going to be updated as well. So with that in mind, I can now, if I go back to my store, it's still empty. So we need to display some info in here. So I'm going to display a first product, a first license plate. So I go back here, and I'm going to add a license plate component. So app license plate, this one was already created. And I'm going to show you what it looks like. So it's a component, of course. Takes 2 inputs. First input is a license plate object. A license plate is an interface I created with TypeScript. And that's another big benefit of TypeScript. We have types. So we have the types from the language itself, but we can create our own types easily. So this is a license plate product. It's going to have an on-sale property. It's going to have a picture, a title, a price. All of these are typed. Have an input, so I can pass that object to my component, and then it's going to be used in the template to render the title of the plate, the description, and everything. So let's do this. Go here, and I'm going to pass a license plate object as an input. So I have one defined in my component right here. I actually have an array of many different license plates that we are going to display later on. And I also need to set a button text. And the button text in our case is going to be add to cart. So I just do these 2 things. save this, go back to my store, and now we have a license plate that shows up. Now this one is a little bit big. I want to make it smaller and take just 1/3 of the screen. So I'm going to add the CSS class to it. And this application is using Bootstrap for CSS. So with Bootstrap, I can restrict the width of my column using this. And now it's going to fit my screen a little bit better. Oops. So now we have 3 components on the screen. We're using data bindings. We're displaying data. All is good. But we want to display more than one license plate. So how do we do that? That's where directives come into play. So with directives, you can manipulate the DOM. You can repeat elements. You can hide them. You can show them. You can make things much more dynamic. So directives are all about manipulating the DOM. And the most common example of such directive is NG4, because NG4 is just a repeat. So you can repeat an element as many times as needed. So this example here would create a list of persons. It would just repeat. So go through the array of persons and create an li element for every single list item that we have in that array. If I apply that idea in my store, so I go back here, and I'm now going to repeat my license plate many times. So I'm going to use ng4. Let license plate of license plates. So that's the array of license plates that I showed you earlier. So I'm going to iterate through that array, generate many different license plate components. And every single instance of that, so every single item in that array is going to be known as LP inside my template. So that's what I'm going to pass as an input to the component itself. So I'm iterating through an array, generating many components, passing the data for each object into that component. And the result is our store with all of the license plates in it. So ng4 repeated 8 of them. And that's it. With just a few components and directives, we have something that looks pretty good. So that's the ng4 directive. Another very useful one is ngif. So ngif is just going to show or hide something based on a condition. And the way it's going to hide something is actually by removing it from the DOM entirely. So you won't be able to see it in your HTML. It's going to be entirely gone when you use ngif. So let's give it an example. What I want to do next in that store is have a tag that would show up here on sale when the license plate is on sale. So some of these plates, they all have a property on sale. Sometimes it's false, sometimes it's true. And when it's true, I want to display the sale tag right next to the title of my license plate. So let's do this. Back to my IDE. I'm going to go to the template for my license plate component. And up here, I want to add an image. So image source equals assets slash, I think it's sale.png. So let's make sure that this works before I keep going. I just add the image here. Yep. So now we have these tiny little sale tags all over the place, and we just want to show them when it makes sense to do so. So that would be when the license plate is actually on sale. So what I'm going to do is just add a ngif directive, and it's going to be based on plate.onSale. And just by adding this little trick, now only the license plates on sale have the tag. So that's another example of very useful directive. And a final one I want to show you is NGSwitch. So NGSwitch is a switch case implementation for Angular. You can do that to do some kind of tiny pagination on a component if needed. So the way it works is you have a NGSwitch that's based on a variable. So here the variable is page. And then you define different cases. So here 1, 2, 3. So if page equals 1, we would see the first paragraph. Page equals 2, second paragraph. And if it's not 1, 2, 3, it falls into the default. So let's take a look at my example for this one. NGSwitch component. So I just have a property page. By default, it's null, just so that we see the no page selected by default. And then I just have 3 buttons to go through these different pages. So when I click page 1, it said page 2.1, which is going to display the first page and so forth. So easy enough. Let's take a look at this one. NGSwitch. So no page selected. I click page 1, first page, second page, third page. And I did some pagination with, very little code in the end, which is nice and easy. Another good thing about this is that it doesn't have to be paragraphs. These could be components. So here I could be using other components from my application. So that's a component that I have called hiding. And if I use that component for page 3, now when I go to page 3, we have an actual component that gets displayed, not just a paragraph or static text. So it's powerful. So that's directives. And the next thing I'm going to talk about is pipes. So pipes in Angular are a way to format data. Whenever you want to format something on the screen, you can use a pipe to do so. And there's about 15, 16 pipes in the Angular framework right now. So most of the common ones are uppercase, lowercase, title case, date, currency, number, so everything that you can format. So, there's many different formats of dates and numbers and all of that. You can use pipes for that. Let's say that in my license plate store, I want all of the titles here to be uppercase all of the time, for instance. Well, I'm going to use a pipe to do that. So I go to my license plate component, and the way we use a pipe in Angular is by using the pipe character and then the name of the pipe itself. So uppercase in that case. And I just apply that to the title, and now all of my titles are going to be uppercase. So instead of changing the data that you get from your backend or wherever, you don't have to do that. You can just do the formatting in the template, which makes more sense because that's where it should really happen. So there's many different pipes, as I mentioned, in the Angular framework. Another very interesting one is date. So date pipe is going to take a date, format it. There's some formats that are provided by the Angular framework that you can already use. So medium date, small date, long date. There's at least 10 different options. And you can also go full custom and say, oh, I want the year to be like 2 digits or 4 digits, and the months to be a string or just 3 letters or just 2 digits. You have all of these options. I'm going to do that quickly because at the bottom of my app here, I have a bug actually. That's a copyright here, and the copyright still says 2018. And unless I change the code every time we switch to a new year, this is always going to be out of date because it is hard-coded in my template right now, which is not a good idea. So instead of doing that, I'm going to use a pipe to solve that problem. So how can I do this? So that's happening in my app component HTML. So in my app component TS, I'm going to add a new property. I'm going to call it now. And now is going to be a new date. So that's going to create a JavaScript date object that is set to right now when you don't pass any parameter to it. And with that in mind, I can now replace 2018 with just an expression that displays now. Let's see what happens when I do this. So I go all the way down here, and I get a very verbose date with everything in it, including the time zone and the seconds and everything. Now, that's not what I want. I just want to display 2019. So that's where the date pipe is going to come to the rescue. If I just apply the date pipe with no parameter, then it's going to do the default formatting, and it's better already, a little bit shorter, October 18th, 2019. But I just want the year, so I'm going to go full custom and pass my own date format here, which is just Y, because that's all I care about with this date. So I do that, go back here, And now my problem is just solved forever. It says 2019, and when we move to 2020, it's going to say 2020. So you can use pipes in a lot of different creative ways. Well, this one is not super creative, but still useful. So that was pipes. So far we saw how to create components and display them on the screen, how to use directives to make the content more dynamic and repeat things or show and hide things. We saw pipes to do some formatting in our components, in our templates. So that's all UI client-side based things. But how do we get data from a server and actually display that data to, well, so that that store is connected to something? In order to do so, there's one final concept of Angular, and that's called services. And services are based on dependency injection. So services are where we're going to put all of the business logic. All of the application logic goes there. So how you get the data, how you cache it, how you interact with the backend, all of that is going to go into services. Our components, they don't have to know about this. They should be focused on getting data, well, having data passed to them and then rendering that data using templates. So a service is a class that we can inject into an object using dependency injection. By default, services are going to be singletons. So you only have one instance of your service for your entire application, which is very handy because you can use a service to share data between different components, for instance. So that's a good use case for this. And in order to turn a class into a service, all we need is the @injectable decorator. So we saw that for components, we have the @component decorator. For a service, it's @injectable. So who's familiar with dependency injection? Okay, that's most of the room. So with dependency injection, the idea is that we don't create the dependencies ourselves. We rely on the framework to do that. So that's what's going to happen here. Angular is going to create the services and pass them to the components or directives or other services that need it. And it's going to do the injection for us. So all we have to do when we want a service to be injected into a component is just ask for it in the constructor. So here I have an example of component class, and that class needs a post service. So I just ask for it in the constructor, and Angular is going to take care of that, create a service, and pass it to the constructor. Now, if I want to create a service, of course, I'm not going to do it manually. I'm going to rely on Angular CLI to do this using the ng-generate-service command, or nggs. And this is going to give me a service. So let's do that. Oh, before I do, one last thing. And that's a very good TypeScript trick to be aware of. So in TypeScript, when you have a constructor parameter, if you add a keyword such as public or private or protected in front of the constructor parameter, it's automatically going to turn that parameter into a class property. So the code here with just that public keyword is equivalent to the more verbose version that you have down here. So that's a good trick to be aware of because, well, it saves a lot of time and a lot of code. You don't have to declare a property and then assign a value to it and all of that. You can just use one keyword and it's done. So that's a nice trick. So let's get into that. Now, what I want to do is have a service that's going to give me those license plates. So instead of having an array of values hard-coded into my main component, which is what I have right now. Everything is hard-coded in here. That's not realistic. That's not how real life works. So I'm going to remove that from here. And this component is not going to have any license plates for now. I can even remove this one. And these license plates are going to come from a service instead. So that's what I'm going to do. I'm going to generate a service for that. So back to my terminal, ng generate service. This service is going to be my license plate service. So let's generate it. nggs license plate, there you go. So you can see that it's injectable, everything is ready. And I'm just going to add one method, getList. GetList is going to return an array of license plate. So I can specify that type here. And I'm just going to return that same array that I just cut from my component. So it's still hard-coded, but at least now it's in a service, which is a little bit better. And in a few minutes, we're going to get that from a server. So it's going to be the real thing. I save here. So my service is ready. It has a method that returns the data. So all I need to do now is use it in my main application component. So how do I do that? Well, by having a constructor. So in my constructor, I'm going to have one parameter. I make it private. This is going to be my service, license plate service. And what I'm going to do with that service is just call it to retrieve my license plates, which is a getList method. So now I'm using dependency injection to inject that service. And again, Angular is going to do all of the heavy lifting here. I don't have to worry about any of this. And I go back to my app. Everything just looks the same because, well, it's the same data, but coming from a different place. So now we have a service. Perfect. Next, let's get the data from the backend. So we are going to use HTTP to do that. So Angular has a service to deal with all HTTP requests. It's called the HTTP client. And that HTTP client, well, you're going to use it for all of your AJAX requests. And it works out of the box with JSON and REST. So it's made ready to work very nicely with that, which means that in the end, when you want to request data from the backend, it's going to look like this. So just one or two lines of code to say, hey, HTTP client, make that HTTP GET request to that backend. And when you get the data, assign it to something in my service or in my component. And that's it. You do that, and you have your data that shows up. So when you make an HTTP GET request, this is going to return an observable object. So these observables, they come from a library called RxJS. Angular relies very heavily on that. And we could spend just a couple of days talking about RxJS. So I'm not going to do that now. For now, just assume that an observable is an object that we get, and we can subscribe to it to get our data. So that's what I do here. HTTP GET returns an observable. I subscribe to that, which allows me to register a callback. That callback is going to get the data when the backend responds. So HTTP client, it's an Angular service, which means we can inject it in the constructor of wherever we need it. So here I have a service. I'm injecting HTTP client into it. And then in a method down here, I just use that to make an HTTP request to my backend and retrieve some license plates. So the nice thing about the HTTP client is that it plays nicely with TypeScript. So when I make a request, I can specify the type of the response using generics. So that's what's happening here. I'm specifying that what I'm going to get from the backend is an array of license plates. So everything is still strongly typed in my application. So let's do this. Let's use the backend and get some data now. So I do need to start my server locally. There you go. So now I have a server running on port 8000. And in order to use it, I'm going to go back to my service. And instead of returning that hard-coded array of plates, I'm going to remove that and use the HTTP client instead. So injecting the HTTP client. So this service comes from the Angular framework itself. Now I need to create it. And now I can do this .http.get. Make my request to localhost 8000/data. And this localhost 8000/data, I'm going to show you what it looks like. So that's just an array of license plates. So, oops. Oh, typo. Yeah, this happens. That's why people don't usually do live coding on stage. Yep, there we go. That's my data. So it's the same array of license plates, but this time coming from a server, which means I have a typo here, so I can fix it. So this HTTP request is going to return an array of license plates. So same idea as before. I can use generics to specify this. And now, instead of returning the data itself, I'm going to return an observable of that data. So that's my service. It is now ready. And my component, so app component, yes. So I'm going to change it a little bit because now it's async. We're going to make a request, get a response. So we have to subscribe to that and have a callback. And then when we get the data, we assign it to our array of license plates. Now, the nice thing about this is that the logic behind how we retrieve the license plates is completely unknown from the component. The component just knows that it has to subscribe to an observable. That observable could be an HTTP request, it could be a WebSocket, it could be reading a cookie in the browser. We don't know, we don't have to know. So it's completely decoupled. So your component is not aware of how it's being used, and that's very nice. Only the service knows that. So that's my code, and now if I go back to here, we should be able to see the same license plates as before, but the main difference is that this now comes from the network. So you can see that there was an HTTP request made to localhost 8000/data. The status was 200 OK, and the response was 8 different license plates. So from a component perspective, it's really just making that request with a line of code, assigning that to a property, and then Angular is going to detect the change, re-render, display my license plates. So we have 2 minutes left. And for these 2 minutes, I'm going to talk about a component router. So far, everything I've been doing here was just one page. We had one page, everything was running in that same screen, and that's good, but most apps in real life, they have multiple pages, multiple screens. So the component router is the solution for that. It's just a way to tell Angular that when we go to a specific URL, we want to render a specific component. So we're going to create a routing table that's going to say, hey, when I go to /login, I want you to display the login component. When I go to /cart, you're going to display the cart component. And Angular needs to know where to display those components, though. So this is going to happen through a router outlet. A router outlet is just a directive that we put in our code to tell Angular that's where you're going to render these routed components. And then we provide the routing table, which is just a mapping between a path and a component. So the demo examples here that I have with all of these links, this is based on the Angular component router. So when I click any of these examples, you can see that the URL changes, and we have a new component that shows up on the screen. All of that is happening client-side. This navigation is happening in JavaScript in the browser. It's not going to any server. So it's good because, well, it's using the browser history, so I can navigate back and forth using the browser buttons. Or I can even hit refresh, and the app gets reloaded in the same state on the same component. So that's what the component router allows us to do. Navigate between different screens, and you can now bookmark a URL and get back to here later on, even if it's just a client-side. So that's all I had, right on time. Thanks a lot for coming. If you have any questions, my email is here. Feel free to write. You can also come to me, ask questions after this talk. The link to my slides is right here. Again, thanks a lot. Enjoy your lunch.